Great. Welcome to UC Love Data Week. Go. So UC Love Data Week, this is the first day of it. And if you please feel free to check out the remaining workshops that are happening throughout the week and register for those. We're going to go ahead and dive in. The slides are for the workshop are available at this link and should be available, but let me know if you have any trouble with them. Just a few housekeeping things. I want to give thanks to Misha Coleman, who is the STEM librarian here at UC Berkeley and who is going to help monitor chat. The chat, because we're expecting a large group today and we've got a lot of materials to cover, please feel free to ask any clarifying questions in chat if something is unclear. But for more detailed questions, we'll try and hold those until the end, just so we can make sure we get through all of the materials. We are recording, and so hopefully the recording will be available soon. If you have any trouble hearing me, please let me know. And feel free to engage captioning if that is helpful as well. All right, I think those are all the housekeeping things. I'll go ahead and get started. So this workshop is an introduction to GIS and digital mapping, and it's a broad overview. What we're trying to cover today is some common terms and concepts that are used within GIS and mapping. I've tried to highlight some key terms in this aqua kind of color on the slides and key concepts in yellow, so keep an eye out for those throughout the workshop. And we're going to cover the tools that are out there. And I just got a note from Misha that my background slide is mirrored. So let me see if I can figure that out, how to change that while in Zoom. It looks good to me, but apparently it doesn't look good. Let's see. Let me find my settings. Settings. Zoom background. Okay, is that better?
I think it was fine before.
Oh, it was fine before? Okay.
Yeah, your slides are fine, Susan. It's just the Zoom background, at least to me, appears reversed.
Okay.
But
I don't see a Zoom background.
Does that look better for folks out there who can see my background?
still the same for me.
Okay. Well, we'll just go.
But it doesn't really matter.
Yeah, it's all right.
Yeah, okay, it's distraction. Thank you all. So let me go ahead back here. Let's see. You'd think I would have Zoom figured out after all this time, but sometimes you don't. So we're going to cover tools that are out there and some resources for how to learn how to use those tools, and then also about GIS data, because that's the other big part of mapping. All right. So I like to start with this quote about digital mapping because I feel like it helps broaden the context of what we're talking about with digital mapping and GIS. And it's really about all the things that you do in relation to mapping, including collecting data, transforming them, how you're planning to share the maps, and the production of maps may or may not actually be an end result of GIS and mapping. So you may make some maps, or you may just do some analysis, and that's the piece that you're interested in. So I like this as it kind of broadens up the concept of what we're talking about when we think about GIS and mapping. But what is GIS? So GIS stands for Geographic Information Systems, or sometimes in Geographic Information Science. And Geographic Information Systems are the technologies and tools that can do all of these things, like with geospatial data. So they can import them, They can help you analyze and visualize those. And they're represented geometrically as coordinates on the surface of the Earth. Geographic information science is the broader conceptual framing for how we do that work. So often when people are talking about GIS, they're talking about the systems rather than GIS science. And one thing that is really nice about GIS systems is that it can help you overlay and put into quantitative relationships different types of data. So in this example, we may imagine we have a layer of elevation or topography, a layer of forest fires, and a layer of forest cover. And we can visualize that in even before GIS and kind of get a qualitative sense of how the relationships work. But with GIS, you can start to analyze the relationships and spatial relationships between those different layers. So it's really powerful way to look at information. All right, so let's dig into the geospatial data first. We use geographic data all the time when we're navigating around, when we're talking about where we live, or where the restaurant we went to last week. And it's really about locations that are on or near the surface of the Earth. So one key term that you may hear is scale. Scale is how zoomed in or zoomed out you are in space. So scale for geographic data can be anywhere from local to the very global, and it is used to describe and represent location on the Earth. We bring a lot of contextual knowledge to interpreting our location. So for those of you who are at UC Berkeley or who may be familiar with Berkeley, you know that the population of Berkeley is a lot larger than 10,000 people. And probably if you saw this sign, you would realize that you were maybe not in the right Berkeley if you saw this on the internet. We have a lot of just kind of information about where we are. Geospatial data, on the other hand, uses mathematical coordinates mapped to the surface of the Earth to define locations. So a computer system, if you said Berkeley, California, needs to have those mathematical coordinates in order to know which Berkeley we're talking about. And that's called a geographic coordinate system. So just to clarify a little bit, some terminology that you may encounter. Geographic data is encoded in a way that humans can understand. So things like that we bring a lot of contextual knowledge to, like place names, addresses, zip codes, that kind of thing, where we're kind of understanding what those mean. Geospatial data takes that geographic information and encodes the location with mathematical coordinates that a computer system can understand. And it's representing space in a geometrical way. And the way that it does that is by using a geographic coordinate system of some sort to model essentially the Earth and then map those coordinates and define locations based on those mathematical coordinates. So geographic data, as an example, this is a table of some famous building locations within Berkeley. We've got things that if you were kind of familiar with the area, you could kind of understand where they are. So it's got an address, which is representing our locational data. And it's got the names of the buildings, the architect who designed them. But if you just gave this to a computer system that wasn't spatially aware, it wouldn't have any idea what to do with it. So geospatial data is where we are adding some kind of geospatial representation to that table of data. It's not always included in the table of data itself. We'll get into that later, but these include the latitude and longitude for the geospatial data that we were looking at earlier. So why would you care about having geospatial data? Well, it's nice because they can be mapped using computer systems. You can do quantitative measurements like measuring area or distance. And really kind of the main power, I think, is being able to see the spatial relationships between different types of data and different data sets. But they also are not as easy to work with as regular tabular data. So we'll get into that in a little bit when we look at the tools. I want to pause just a moment and look at the kind of geospatial world, though. So if you imagine a globe, and let's think of that as an orange, and then you try and peel that orange and make it into a two-dimensional representation, you're going to have to sacrifice some truthfulness to the data. And in this case of the orange peel, we're sacrificing some connectivity between places. You may also distort area, you may distort the shape, the directionality, the distance. So there's a couple of key ways that things can be distorted. So when we're talking about maps, they're a flat representation of the Earth, and they necessarily involve some kind of distortion. A map projection is a way that we're taking that spherical object and flattening it onto a two-dimensional plane. And the coordinate reference system is the way that is the system that we end up with. This is all by way of saying there's just complications when working with geospatial data that may crop up. And if you're interested in learning more, there's a link in the slides to thinking about coordinate systems. And the other reason that this matters is because the mismatch of coordinate reference systems is one of the most common issues that people run into when they're working with GIS data. And in this example, you can see that we have 3 different map projections, all centered in Nebraska, I think. And you can see that at the center, they're pretty well lined up. But when you get to the edges of the extent of this map, you are seeing very different locations for the different data. So if you were trying to overlay, let's say, like the Olympic Peninsula in Washington with different data and different projections, they would not line up well. So it's just something to be aware of, and you can learn more about it if you want to. But if something is happening where your data is not lining up, this is a common cause. So let's talk a little bit more about the data itself. There's 2 main kinds of geospatial data in the way that it's represented. One is vector data, which is really concerned with objects in space. So with vector data, it's thinking about where objects are, and it's defining those as either points, lines, or polygons, which are areas. And the attributes you can think of as the column headings. So it's telling you something about that geometric representation. Each line in the table represents a separate feature. So you can have multiple features in your table of data. And then the kind of hidden part to many geospatial data is the geometry itself. It doesn't appear in the table of data, but each of these features is associated with a geometry of some sort that's stored in a separate way. And when you get a group of features together, that's called a layer. Now, the other main category of geospatial data is called raster data. And rather than looking at the world as a group of objects, it's looking at the world as a field, a continuous field. So things in space that vary continuously variable, are often represented with raster data. You can think about something like elevation or temperature, where there may not be clear lines between the different variables. And that's where raster data comes in handy. It's represented by a series of grid cells where they have a regular dimension in the X and Y axes and a regular number of rows and columns. And then each cell contains a variable value. So in this example, it's a digital elevation model, or DEM, and each of the grid pixels, essentially, in the raster data contain one value for the average elevation in that cell. Right. So one last thing I guess I'll say about raster versus vector data is you can translate between the two, and you can represent, let's say, elevation as both contour lines or as raster data, but you lose some accuracy when you translate between the two. So that's one thing to be aware of if you're thinking about raster versus vector data. All right. So some common file types you may encounter with geospatial data. One of the most common historically has been shape files, and they are actually confusingly named because a shapefile is actually a collection of several files. In this screenshot, I've got Berkeley Groceries 2016 as my shapefile, but it's actually a collection of 6 different files that all have different kinds of information stored about the data set. And if you lose one of those subfiles, you'll lose some important information about your data, and sometimes it may not work. So when you're moving them around, it's often helpful to send them as a zip file rather than as a like unzipped file. And you want to make sure that the root name stays the same for all of those, because that's the way that the software interprets them as being part of the same shape. There's also geodatabases, both Esri and file geodatabases, which contain lots of different kinds of data. You can find geospatial data in CSV or Excel files with X, Y, or latitude and longitude kind of embedded within the tabular data itself. And then there's a variety of other kinds of more human readable files like Google KML, KMZ files, and GeoJSON. And TIFF and JPEG are the most common image file formats for rasters, but there's other ones out there as well. So finding geospatial data can be an exercise in patience and adventure, but some places to start are thinking about what your local library guide might have, and then some questions to help guide you in your search. So where are you looking for data, and what are you mapping? Another question is, what is your geographic scale? So maybe you're looking at you're interested in the state of California, but do you need to represent that data at the county level? Are you interested in mapping it at a smaller level or a more kind of individualized administrative level? And then in terms of finding data, sometimes it can be helpful to think about who might have produced the data that you're interested in, and then go explore their website or talk to someone at that agency. So the screenshot here is just one example from the library guide at Berkeley, but there are many guides out there, and they tend to be tailored to a specific region as well. So if you're interested, especially in local data, it can be helpful to find, let's say for Los Angeles, maybe the UCLA guide would have more specific data. I'm going to highlight a few that are some of my personal favorites for finding just kind of general data. One is called Natural Earth. And the reason I like this source is because it was produced for creating pretty maps. a lot of the data that you find out there may be great for analysis, but doesn't look so good if you're trying to produce a finished map. So Natural Earth is designed by cartographers for cartographers and has data available at different scales. OpenStreetMap is kind of like a crowdsourced Google Maps. And one of the nice things about that is, there's two really nice things. One is that you can contribute yourself. So if the data doesn't exist for a region that you're looking for, you can digitize the data yourself from satellite imagery and contribute it back. And you can also export data that exists within OpenStreetMap, unlike with Google Maps. So you can export and extract the data to work on in your projects. ArcGIS has a living atlas of the world collection, which, especially if you're involved with ArcGIS Online or Esri products, is a nice kind of entryway into geospatial data. They tend to be already styled nicely and can be integrated into existing into projects. And then I just kind of on the opposite end of the spectrum of kind of ready to use, but still very nice, is the Geospatial Data Gateway from the Natural Resources Conservation Service, which has just a nice, simple database listing of lots of different kind of natural resource material, GIS data, and it's you have to download the data, but it's a nice one-stop shop for a lot of that hydrology, land cover kind of information. So those are just a few highlights, but there's a lot of data out there. And I think it's definitely it can be a big part of any GIS project is finding the data that you are going to use. One last note about data is sometimes you have geographic data. Let's say you have a table of addresses. You understand what the context is, but how do you get that into a machine readable format? How do you translate that geographic data into geospatial data? There's a couple of options. One is called geocoding, which is kind of like working with Google Maps, where you enter an address and it recognizes the geospatial coordinates for that address. And the way that Google Maps is doing that is by running it against a database that's hidden behind the scenes. So geocoding is a way of doing that with like a whole batch of data for geospatial to translate a series of addresses or a place names into geospatial data. And there's various options for doing that. And I think reaching out to your local campus folks may be the best way to find out the details of what's available to you on your particular campus. And then another way to get from geographic data to geospatial data is what's called a table join, where you may have some kind of key field, like in this case, a FIPS code or a specific code for a county. And it's we can use that as a way to map, essentially, or match our data of kind of tabular data, which is population, let's see, what is that? Population data, percent population change for different counties, to a geospatial data set that has the geometries that we're interested in. So that can be another way to create geospatial data from geographic data. All right, I'm going to pause there just a moment and see if anybody has any clarifying questions. And again, we'll hold kind of more detailed questions to the end, but if something isn't making sense to you, it's probably not making sense to someone else. So I'll pause and drink some water and see if anybody has any questions. Okay, not seeing any questions in chat, so we'll move ahead. But again, feel free to ask any clarifying questions. So this next section is really thinking about how to think about your mapping. Oh, and I just see a question in chat. What files does QGIS use? It can use a wide variety of files. So, so there are some formats that are proprietary to, especially the company Esri, that may not be supported in QGIS. But I think the vast majority are supported by QGIS at this point. Good question, thank you. All right. So the types of mapping that I've outlined here are very loose categories that I've just kind of developed after the years of supporting people with different kinds of mapping and GIS projects. And they can definitely be overlapping, and you might have a project that involves all three, but it can help you start to think about which tools may be useful for your projects. So one is narrative, or you're trying to tell a story with your mapping and your data. Another maybe is descriptive, where you're trying to just kind of describe the spatial relationships between different data or data sets. And these can be just a simple illustration for a paper showing location and relative spatial locations. And then analytical, where you're really trying to get into the kind of quantitative relationships between different data sets. And all of these, as I say on the slide, can be found in a wide range of disciplines. Just to show a couple of examples of which ones I'm talking about, this is an example of narrative mapping that I like, where it's using a platform called StoryMaps.js, and it's really walking you through the different locations telling the story of this person's life. And you can embed different media, you can include text, and really kind of give a linear outline to a story. An example from more of the descriptive mapping category was created with Matplotlib, which is a Python library. And it's simply showing the tracks of Atlantic hurricanes that reached Category 4 between these years. So it's really just kind of showing you where these hurricanes ended up. And then for more of an analytical mapping example that also includes some of this narrative aspect of things is a map kind of atlas that was created with the ArcGIS Story Maps platform, where it's analyzing different variables to explore what like impact factors for community health and climate change in the Vancouver area. So these are, again, overlapping categories, but can be a helpful way to frame when you're thinking about where to get started with mapping. So we have a quick poll here. Let me find my poll settings. And we'll launch this. Thinking about these, again, broad descriptions, and you can choose more than one, I think. What type of mapping are you thinking about doing in your work? Just a minute, a little bit more. Okay, looks like it's slowed down. So as you can see, it's pretty close, neck and neck. I think at the very end, analytical kind of slid in there with more. But hopefully that's helpful to think about when you're getting started with mapping, what are you interested in? And it may be a variety of those things. All right. So let's talk about software. Again, why would you need some special software to work with geospatial data? Most software only understands numbers and text, and it doesn't have that spatial understanding of the geospatial aspect of the data. So geospatial data requires software that can understand that what the data that you have has this geospatial representation involved. Again, these are very loose categories in some ways, but there's web mapping tools that allow you to do more of kind of a narrative description. There's web GIS software that is a little bit more analytical in capability, but still based in a browser. There's desktop GIS software that you install on your computer. And then there's programmatic approaches where you're using some kind of programming language to interact with the geospatial data. And in addition to having kind of overlapping relationships to the narrative, analytical, and descriptive categories, they're also more and more kind of blending between these two. So in some of the desktop GIS softwares, you can do some programming. The web GIS software and the desktop ones are starting to kind of have more relationships between each other, but it's helpful to think about, for me at least, between these different kind of broad categories. So we're going to dig into each of those in a little bit more detail, but I'm going to first give you an overview of what a basic GIS software might look like, whether it's web-based or browser or desktop-based. So within any map that you're mapping project that you're doing, you have a few different things that you'll interact with. One is the layers of data themselves. So these are the data that you're importing into the map and symbolizing or analyzing in some way. In this case, I'm using Google My Maps as the tool, and I've included a layer of businesses that have chicken in their business name for the kind of city of Oakland and Berkeley. So that data in my layer is symbolized as, in this case, I've chosen to symbolize it as a little chicken, and that is, I'm mapping my point data as these different little chicken symbols. But I could choose a party hat or a big circle or some other way to analyze or represent that point data. And then underlying my layer data is a base map. And that can be a way of giving some context to your layer data without having to add and style the data that is underlying it. So it usually includes things like roads or place names. If you're in it will often be zoom dependent. So if you zoom in more, you'll see more information, more detail. The nice thing about base maps is you don't have to worry about the base map part. The limitation is that they are preset. So you are working with whatever is given to you. And chickens just sounded fun. I don't know. Yeah. I was probably hungry that day. So one key point that I want to emphasize, because this trips up a lot of people, is that there's often a distinction between the map document versus the data that's within it. And the map document is really about how that data is styled and symbolized, which is stored within the map document. And the data itself, any information that you add or change or delete from the table of data, that data layer is stored within the data layer itself in the shapefile or the KML file or the GeoJSON, whatever way your data is stored, that will be the changes to the data itself will be stored with the data. Versus, let's say if I changed my chicken symbol from a chicken to a star, that would be stored within the map document. So that's one kind of key distinction to make between the maps and the data that's within it. So web mapping software was originally developed with the idea of communication and sharing mapped data more broadly, especially in interactive ways that the digital products allowed for. It's typically a little bit easier to get started with than desktop GIS software, although that's not always the case now. And there's kind of, over the past few years, there's been more convergence where the more analytical tools are being included more in web mapping software, and the desktop tools are becoming a little bit more user-friendly. So see there's a question in chat. Let me just, there's the last point on this slide, which is that for data that requires really analytical, kind of like special analysis or confidentiality and security issues, where putting something into a web browser is not secure, you may think about using a desktop platform for that. And there's a question in chat about clarifying what is considered to be the map document as opposed to a layer. So let me go back just one slide here. Oops. So the map document is is often stored as a separate file on your computer or within a web GIS. And it's storing information about what data is included and how that data is symbolized versus the data itself. So it's basically stored as a separate file, the map document. I hope that helps. But I'm happy to go into more detail in the Q&A at the end. All right. So this is, I'm not gonna run through this whole list. And let me just go back to this to follow up on the question, is a map document like a metadata? Good question. A map document is not really like metadata, I guess. The metadata is information about the data itself. The map document is storing information about how the map is displayed. So it's really kind of a display map file rather than information about the data itself. But good question. All right. So here's a couple of examples of digital web mapping tools. This one is the story map.js tool that we looked at with the biography. And again, it's kind of, it's good for showing narrative, linear, kind of guiding people through a story. There's also Cardo is a kind of vaguely free, but also has some paid, more options with paid subscriptions, but it allows you to do a little bit more analysis and also some fine tuning of the way it's displayed as well. And then I want to highlight ArcGIS Online and Story Maps because they're commonly used and they're licensed through the UCs. They are a good way to both access data through the Living Atlas and other users. You can create and edit data, perform some analysis, and create web maps, which you can share with other people. ArcGIS Online is kind of the mapping piece of it, and then Story Maps is the more polished narrative way to show that. And it really has this kind of ecosystem of connected apps. Each UC campus has a license at this point, I'm pretty sure. But to get to your individual instance for your campus, checking out this link for the UC GIS Hub page will give information for each campus about how to access your specific instance and access. And I think Misha will put that in chat in just a minute. So let me do a quick demo. Check the time. I think we have time for ArcGIS Online. This was the icebreaker for those of you who were here at the very beginning. We had our let's see if I can get this to work. We had our results map, which is kind of pretty looking here. And, you know, it's not the prettiest map, but it's serviceable. And we can zoom out here and see, you know, people were spending their summers mostly in California, but also in various parts around the world and the country. So this is, you know, a map that you can interact with. The map that's driving it, the ArcGIS Online map, is this map here. And you can see I'm logged in as myself, so I have a few more options than you would, but you can, you should be able to open this up as well and play around with some of the symbology. Again, that map document is something that you can edit and control and make a copy of. The data itself is stored within my content, and so you would need to make copies of the data in order to be able to edit that. The other point I wanted to make about this is that it's the same underlying data set that you filled out with your favorite color and your location. And I've added it to the map document twice in order to symbolize it in different ways. So in one case, I'm interested in showing where what favorite color of that person was. And the heat map gives you a broader sense of, when you're more zoomed out, okay, where are there clusters of data? Where is this point data being clustered? So it's the same data. And if I changed any point in the underlying data, let's say another person added a response, it would show up in both of these layers. But I'm symbolizing it in different ways. All right, go back to present mode here. All right, so desktop GIS software has a lot of analysis capability, is very powerful for doing different kinds of analysis, lots of functionality, and especially with QGIS, but also with ArcGIS, you can find kind of ways that people have like special programs or things that people have built to increase the functionality. And there are decent visualization options within these. They tend to have a somewhat steeper learning curve. They're designed, especially at the beginning, to be more interested in, kind of more geared towards people who are using GIS software as part of their daily routine. And there are ways to integrate, again, kind of between desktop GIS software and web mapping tools, but hosting the maps is a separate issue. So with ArcGIS Pro and the desktop software there are ways to kind of work with your ArcGIS Online data in ArcGIS Pro and vice versa. And with QGIS, there's ways to export to kind of web mapping formats, but then hosting the maps is another issue. So they're still kind of, I think of them as distinct options. There's a variety of popular desktop GIS software. The two I'm going to highlight are QGIS and ArcGIS Pro, which is replacing ArcMap. And ArcMap is really, really going away now. For those of you who may have been familiar with it in the past, it will no longer be licensed starting in this coming summer. So QGIS is a good option if you use a Mac or a Linux. It's free and open source, so you can use it even if you're no longer associated with a university or a company that licenses other software. It's fairly stable and has a large user population that builds a lot of plugins that can be used to expand its capabilities. It still has kind of a somewhat steep learning curve in terms of figuring out which buttons are where, and doesn't have quite the same robustness as ArcGIS Pro, but it is a very well-featured desktop software, and I highly recommend it. And there's a lot of good documentation out there for it. Esri's ArcGIS Pro only runs on PCs. It is licensed through the UCs, so you can get access through your local campus. It has a lot of powerful features and lots of specialized tools. And it can, again, connect with your ArcGIS Online account. Like QGIS, it has a fairly steep learning curve, but the thing that I like to note to people is if you get started with one mapping tool, it'll give you a lot of foundational knowledge that you can then translate between different mapping softwares. So in some ways, it doesn't matter which one you get started with, as long as you're learning along the way. So to access the desktop products, you can probably find some installed in local computer labs, in libraries or other specialized labs, and you can install them on your personal computer. QGIS is a free download, so it's more straightforward to install in some ways. And for downloading and installing Esri products, check with your local campus representative to find out about the details for that. And again, you can find out more details about your specific campus on this UC-GIS Hub page. I want to spend just a little bit of time talking about programmatic approaches. There are many different kinds of things that you can do with programming approaches. And I've highlighted a few of the more common languages that are used for different things, but the ones that you'll often hear people talking about are Python and R, and for web mapping, JavaScript. And then if you're getting into geospatial databases, you may be interested in something like Postgres or SQL. But there's a variety of other ones that can be used for different kinds of things that you might be doing with mapping. And I'm just gonna gloss over this slide, but basically it's just a way to illustrate that there are a lot of different packages out there for using the mapping tools within different mapping packages within the different programming languages. All right, so let me my controls here and launch the second poll, which is which mapping tool you think you might explore as part of this your exploration of mapping in GIS. And I see there's a question in chat here about does anyone have a recommendation for a step-by-step hands-on mapping tutorial? And there are a couple of recommendations further on in the slides, but I'm also, if anyone has any specific ones that they've found useful, that would be welcome in the chat as well. All right, I'm gonna go ahead and end the poll, share the results here. Looks like people are kind of interested in a variety of things, but looks like maybe more QGIS than ArcGIS Pro users here, and I'm always happy to see a healthy number of Python folks as well. All right, so let's go ahead and move on, and to the perfect segue into how to learn. So there are lots of options. Some general ones that are out there that I have found useful are what's called a gentle introduction to GIS. There's which is giving kind of various tutorials to GIS in QGIS platform, but I find it helpful for the conceptual overviews as well. And then there's some other resources listed here as well. And sometimes it can be helpful to find tutorials that are related to the disciplines that you're in. So I've listed the Spatial Humanities workshop. A few of them are a little bit outdated at this point, but I think they're helpful still in kind of thinking about how humanities scholars might have conceptualized using these tools in their work. There are a lot of tool-specific trainings that are out there. So again, someone mentioned in chat that the Esri has a lot of trainings out there, and they have a lot of good lessons. You should be able to access them again through your campus account. If there are some that are more restricted, there's some that are publicly available. And then QGIS has a bunch of different tutorials listed, as well as some recorded workshops from various QGIS North America conferences that have happened. And then there, again, there are tool-specific ones for programming languages. So there's some really great resources out there for both Python and R that walk you through some of the more specific packages and how to use them. In-person and or virtual workshops that are taught live can also be a nice way to immerse yourself. There are many different UC campuses have different workshops that may be offered either virtually or in person. So check out your local campus. The UC A&R has a virtual training series that's available to any UC person, and I believe the public as well. And that's a good kind of foundational series of trainings. And then a lot of community colleges will also often offer kind of relatively inexpensive workshops that are a deeper dive, that especially if you have grant funding or something, may be a good option. I think it's the self-teaching and workshops are a great way to get started, but I highly recommend, especially for students, that if you're really interested in diving into GIS and mapping, getting a foundational course for their semester or quarter can really give you the best foundational knowledge to then go and explore different tools and softwares that might be out there, and really give you a better sense of kind of how everything comes together. So that's my take, but I think, you know, self-teaching is definitely an option. But if you have the option and availability to take a class, I think that can give you really the best solid foundation. There may be minors or graduate certificates available depending on the campus that you're at, and those can be a nice way to kind of string everything together. And lastly, there's ways to connect with community, and I think that's also a really great way to learn. So there's local campus resources on the different campuses. There's a UC-wide GIS Slack where people ask questions and maybe come to talk about the different applications. And then each November, there's a UC GIS week where it's a mix usually of kind of people talking about the research that they're doing, and then also perhaps providing some kind of more informational workshops as well. And I wanted to wrap up with just kind of a thought about where do you go from here? How would you get started? So for me, what I recommend for people who are looking into kind of getting started with a mapping project and learning is thinking about your goals and audience. So really, what kind of mapping are you trying to do? Who are you doing it for? And then it's never a bad idea to try and sketch something out on paper. I think it can help you get out of the tool mindset and really clarify some of those questions about what you're trying to do and what kinds of data you might need to do it. Like with any big project, it can be helpful to start with a somewhat small subset of your data and test that out in different tools to see kind of where the roadblocks are before you invest a lot of time in trying to figure out, you know, especially with data collection projects or projects where you're using a lot of different data sources, it can really help to kind of start small and then have fun learning, because it really is a process. When you go through the tutorials, everything has been worked out already and it goes really fast. Every single person who has worked on a GIS project that I've talked to, there's like 80% of your time is figuring out how to do something. And then, you know, you write it up at the end and you're like, oh, that's very easy for someone to replicate. But it's really a process. So be patient with yourself and have fun. And I think I will end there. We have 3 minutes for questions. So if there are any questions, I'm happy to answer them here, or feel free to follow up with me or with your local campus GIS folks, and they're a great resource. But thank you all for participating and for your interaction in the polls, and for being here today, and enjoy Love Data Week. Okay, there's a question about my favorite geocoding service. That's a great question. I think if you have access to it, the ArcGIS Online World Geocoder is a good solid option, and can handle large data sets. So that's probably my go-to. There's a question here about, can you create a PDF map that you can zoom in and not see blurred or pixelated? Yes, absolutely. So I think that raises the question of just kind of the resolution of your original data, and what scale you're interested in mapping at. So you would need to think about those questions, and then also the resolution at which you export the PDF map from the software. And there are ways to create vector PDFs, I believe, vectorized PDFs, but that would be something to look into as well. All right, there's a question here about ArcGIS Online being free for individual use. That is true. There is a free version. It doesn't give you as much functionality, either in terms of analysis or the data that you have access to, as the licensed accounts. So that's something to keep in mind. But it does have a free version that gives you some access to the analysis tools and hosting. And the nice thing about ArcGIS Online too is that you can control your sharing settings. So it's possible to keep things private that you don't want public. And that's true even with the public accounts. But there are some issues working between free accounts and institutional accounts. So that's something else to keep in mind with ArcGIS Online. Okay, let's see, I think there's a follow-up question about any learning advice for people getting started. I think just check out those resources and find what model of learning works best for you. For some people, that's having an instructor or going to a live session and forcing yourself to go through the things. And some people, it's reading about it and working through stuff on your own. But I think always having a project in mind and that you can keep the skills up is a good way to go. And there's a question, I think this will be our last one, about any affordable resources to get GIS certified. Again, I think community colleges can be a really great resource for that. It depends on what kind of certification you're looking for, but many times they'll offer a series of classes and offer some kind of certificate at the end. All right, well, I think that brings us to the top of the hour. I'm going to pause our recording. And,